Hello everyone. Today is the 26th day of Leetcode 75 challenge. Let's begin with the 26th question. Question 394, decode string. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So what you are given? You are given an encoded string where some parts are compressed using the format k encoded string. Fine. We will understand this part. So here k is a positive integer that tells us how many times to repeat a string inside the brackets. Fine. So if it is 3a, so this is k and this is the encoded string. Fine. So this a will repeat 3 times. So it becomes triple a. Fine. That's the thing. So basically the question is asking that the number which is before the open and close brackets, this character or this string should repeat this number of times. Fine. Also, encoded string can be nested. Fine. Here you could see it is nested, right? And 2 comes before this C, correct? And 3 comes before this complete character or string within that bracket, right? So output comes out to be A, C, C, A, C, C, A, C, C. Fine. We will understand this in more depth when during our input output explanation. So you need to decode the string and return the fully expanded version. We just have to, these are two brackets. Open this bracket, we get a string. Fine. Then we open this outside brackets and we get a resulted long string, right? This is what we have to do. You can assume input is a valid, proper brackets are given and proper format is given. You don't have to worry about it. And also these are only used for repeated counts, right? So the digits are only representing the number of times a string or character would be repeating, and it is not a part and it is not a part of a word. Fine. So you don't have to worry about that also. The goal is to expand the string by decoding all the bracketed parts. Fine. The problem is pretty easy. I hope you understood the explanation. The constraints are that length of the string would be from 1 to 30. Then S will consist only of English letters, digits, and square brackets. Fine. And S is guaranteed to be a valid input, so you don't have to check or put any edge case about invalid inputs. Fine. And all the integers in S are from 1 to 300 range. Correct. So I hope you got some understanding of the problem. Now let's move to the next slide. Now let's understand the input output explanation. Fine. Now make let us try to make this problem much clearer using this explanation. So this is what it is given to us, right? So this is k and this is the encoded string. Fine. Okay. So what happens? This a will be repeated 3 times because k comes before a as per the question. Now we are remain with bc, 2bc. Fine. Now 2 comes before this encoded string, right? So this gets decoded in the form of bc, bc and again one more bc. So this is our output. Yes, it matches our given output in the example test case. Fine. Now let's check for the another one. Here you could see we are given 3a 2, then c we are given within the bracket, and this is the major bracket. So if you can see 3 is k here, right? And this is the encoded string. And within that, you could see this is another k and this is the encoded string. And keep in mind, always the number which is given will represent the upcoming character or the adjacent character to it. So the number of times it will get repeated. Fine. So C will be repeated 2 times now. Fine. Now this becomes after opening this bracket, we get this. Now this complete bracket will be represented, or this complete encoded string will be represented more 3 times. Fine. So it becomes ACC, then ACC, then again ACC. Okay. So this is what the input output explanation is all about. And I hope you now understood what question is asking us to do and solve. And now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Fine. So let's do it by imagining that we are solving a coding problem and you are given an expression with multiple nested brackets. So what is a nested bracket given to what? Let us write it down. Okay, 2 plus given 3 multiplied by 4 plus 1, then the bracket gets closed 3 times, and 7, then bracket close. Okay, this is what is given to us. And just like the math, you don't start from the outside, you go straight into the deepest layer first. Now, if this problem is given to you, this mathematical problem, what do we do for it? What are you gonna do about it, right? The first thing which comes to your mind is the rule of BODMAS, right? This is a mathematical rule which basically says bracket B means bracket of division, M means multiplication, then A stands for addition, S stands for subtraction. Fine. So this full form is bracket of division, multiplication, addition, subtraction. So first we solve the bracket, then we solve the division, then we go for the multiplication, then we go for the addition and subtraction. This is the level of solving the problem of BODMAS. So if you see here, we just try to solve the innermost bracket first, right? Let me clear up this part. Okay. Since this rule of BODMAS is teaches in our junior classes, so I hope you know the rule of BODMAS. So let's implement this and refresh our memory for once. Okay, I will just write here in smaller way bracket. Okay, of division. Div means division. MUL means multiplication. ADD means addition, and SUB means subtraction. Great. Okay. So you first solve this part. First inner bracket, right? This is what the rule says. So it becomes 5 and you remove this bracket. Correct? Okay. So you remove this bracket and you remove this value. So you get 5. Okay. Now again the inside bracket will be solved. So 3 into 15 gives us 3 into 5 gives us 15. I'm sorry. Okay. So this bracket is also solved. I will remove this bracket. Now we get 15. 2 plus 15 gives me 17. So this inner bracket is again solved. I will remove this bracket. So I get 17, right? Yeah. So we're left with this bracket 17 minus 7 gives me 10, right? So this bracket is also solved and this is our expected output. Now, you will be thinking that why we use this concept, right? We use this logic because if you could see the problem which is given to us is similar to this kind itself, right? Just you have to solve the nested bracket first. Then in the example which you saw, this is C, right? Then you saw that here we have 3 and we had A here. So what we were doing, you were just solving this bracket, then you were solving this bracket. So basically we were following a BODMAS kind of a rule here. So that's why I just wanted to refresh this memory. So this is what we did. Understanding the goal. The expression contains operations wrapped inside multiple levels of parentheses. Yes. To get the correct answer, we must always evaluate the innermost expression. This is the logic. Okay. This is the rule of BODMAS. Please keep that in mind. Once an inner expression is evaluated, we use the result as a part of the outer expression. As we did here, we got first what? We got 5 first, then we used that to get multiplied by 3, right? Here, 4 plus 1, you got 5. Then you multiplied it by 3, right? From inside, you kept on operating the layers, correct? Now, now to understand the visualizing the process, right? What we did, we just scanned each character in the expression one by one, right? So now let's visualize the process in much easier way. So I'm writing this expression online again and focusing on this expression because this will eventually lead us to the solving the problem. So if you have observed, this is the opening bracket, you were not doing anything, then you were not doing anything again, you got another bracket, you were not doing anything, you got another bracket, you didn't do anything. As soon as you got the closing bracket here, the first thing which came to your mind was bracket according to the BODMAS rule. So you tried solving this, right? Correct. After you solve this, please pay attention. Please, I am requesting you to pay attention in this case. As you solve this, you remove that bracket and you got a value 5 here. Now you saw that, okay, this is done. Now you just move ahead. Bracket is removed, right? Then you moved ahead. Consider that you didn't know that closing brackets were ahead, okay? After solving that bracket, you came to understand or know that, okay, we have another bracket here. Then you solve this bracket, right? Then after removing this bracket, you moved ahead, finding for more closing brackets. Fine. You got 15 here. So you got another bracket. So if you can observe here, what's the thing? Every time you see an opening bracket, you know you are about to enter a new level of computation. So as much as you cross the brackets, you are going deeper and deeper and deeper. Fine. And every time you see a closing, you have completed one mini expression and time to evaluate it. Correct? As soon as you find the closing bracket, you get an understanding. Okay, yes, I have got a val or a closing part. Until and unless I don't solve it, I won't be able to go ahead. What a rule says, a Bagmas rule says, right? So what you do, you solve this, then you store it here, and then you move ahead so that you could get another closing bracket so that you can solve the another mini expression. Basically, as soon as or as much as you keep on it basically means that you could understand. Okay, I hope you understood this. Not at all, but I hope you understood what I'm trying to say here, right? So now let's take the original example for the given problem and try to find out. Use this same logic in that also, right? So you understood Bodmas? You understood what as till the time you don't get a closing bracket, you keep on going inside because as soon as the closing bracket as soon as we get the closing bracket, it represents a mini expression. Until and unless you don't solve it, you cannot go for the further expressions or closing brackets, right? And it keeps on going this way. Now, how we can simulate this in our original program, right? Let's take the example 3a. Then we get 2 here, then we get C here. Let's take this example only, okay, for the right purposes. So we need to store and manage different parts of the expression as we go. Now we're solving a coding problem, right? And we need some data structures to use it. In this problem, we need a data structure to use it, fine. So how we will do? So what I thought of that we have a count here and we have brackets and the expressions, fine. What if I take one bracket in this one data structure. What if I take a data structure, let it be D1 and let it be D2, fine. So this is one data structure and this is one data structure, right? Now don't worry about what data structure is going to be, right? If you have understood it well and good, please move ahead and solve the problem. You're doing great. But if you have doubt, please just focus on the intuition. Okay, now what we did, okay, I got three. One data structure I will be using for storing the characters and decoded strings, fine. And one we will storing for the numbers, fine. Now, what we will do, why we will be scanning the string. If we get three, we will store it in D1. Fine, we move ahead. We got an opening bracket. We will try to save it here. Great. Now we move ahead. We got A. Okay, we store it here. Now we move ahead. We got 2. So we stored it here. Now, if you can observe, this is same as the expression of doing the one which we solved before. This one. It's similar to that only. We are getting an opening bracket, we are storing it and moving ahead. We are not solving anything, right? And we are storing the number here. Now we got another opening bracket. We stored. We got another character. We stored here. Now we got closing bracket. Okay. What does closing bracket represents? Closing bracket represents, hey, you just have completed one of the mini expression or you just got end of the one of the mini expression. Now please solve that expression. So you got C here and the closing bracket. So okay, this is one. See here. So it becomes this way, right? So what we do? We don't store the closing bracket. Why? Because we don't need it, right? Why we will be storing the closing bracket? So what we do? Okay, we will pop C or we will take out the C from here. Okay, and we will also remove this bracket because we don't need this because this is one complete mini expression and it is going to be solved now. So now in our hand we have C and we will go and check. Okay, we what is the latest character in our one of the data structure. So remember it is 2. So we take 2. Okay. So C will be multiplied 2 times. So we get 2 times C. Now our expression becomes 3A C C. If you have observed, we literally use the same concept which we used in solving this expression 2 plus 3 or using the Badmas rule, right? So you solve this mini expression, you multiplied it by 2 times because what it is what our question says, and you got this as the result, right? Now this is another mini expression which you have to solve. Now you will remove 2 from the data structure because it is of no use. We used it, right? Okay. Now, since this is the latest expression, what you do is that you store this expression here. Okay. Basically, you pop this CC into the, or sorry, push this CC into the character data structure. Fine. Now you move ahead. You see, okay, we get another closing bracket. So what you do, you just pop out this complete character, right? And you pop out the latest number within present within the another data structure. Okay, it's three. So what you do, according to the question, you multiply it three times. So you get A, C, C, A, C, C, and A, C, C. And after that, you see the string is over. So we got the resultant, right? So this is the thing, this is the complete understanding of the problem or the intuition buildup. If you could just read the theory, if you see a digit, we store it in the count stack. If we see opening bracket, we're entering deeper instead of in a nested layer. Okay. If we see letters, we keep adding them to the current part of the string. Okay. Now, when we see a closing bracket, that means we have reached the end of the complete bracket block. We pop the recently built substring. Okay. Then we pop the recently count from the count stack. Then we multiply the substring again, and then we push the newly created expression again into the string stack. Fine. Now this pattern continues for every new starting bracket and for the closing bracket. We resolve the latest complete bracket using the most recent count. Fine. I hope you understood this intuition. What we're doing here now. How we're gonna solve it and what data structure we're gonna use, right? What we figure out is that the reason this works is that each count is always followed by its matching bracket, and the brackets are nested, not overlapping. Okay, if you have observed, the brackets are always nested; they are not overlapping, right? Not on top of one another. And also keep in mind there is a character, there is a number, then there is an opening bracket, then there is a character, then is an opening bracket or some values present within it, right? And then again something like this, correct? So what this means that after every number there would be an opening bracket. Fine. So this is the thing which you understand. That's why when we are using two data structures to store here, you throw the number here, which means okay, you got the initial starting bracket. Then you throw this correct starting bracket here. Now when you throw this two again here, after throwing a, then you know that okay, another nested loop has started and this belongs to this value and this three belongs to this bracket. Then again, just forget about this. Again, you throw these three here and you throw this bracket in this data structure. So you from here you understand that this three belongs to this expression, this two belongs to this expression, and this three belongs to this expression, right? That is the reason we are using two data structures. And so by always resolving the most recent complete bracket, we can construct the final string correctly from inner to outer. Also, you have observed that we are always popping the recent value or the latest value from the data structure, right? Or always the topmost value. Or also, or another word, you could also say that most recently used value. Okay. So from here, we could say that this is a stack-based question, or the simulation of stack could be used here, or the logic of the stack could be used here, because if you have, I know you have paid attention very nicely in this question. This question is very interesting one. First thing, if you have observed, we always take latest value to pop. Yes, we push the value again. Third, to have the nested brackets in order. Okay, you have always seen we are popping the popping the latest value from the stack from both. We push the value again back to the stack. Okay, it becomes the latest one. Also, to have the nested brackets in order. This bracket will always come before this bracket, right? And this bracket will always come before this bracket. So if you're using stack and you pop this or push this brackets, the nested bracket or the deepest bracket will be used first, right? then the furthermore brackets will be used. So these are the three most important reasons why we are using stack in this question. So I hope you understood the intuition build-up from understanding the rule of BODMAS, for then going to solve this problem, a small explanation, understanding how brackets work from inner to outermost brackets. Okay, then we try to understand how we will use this exact same logic into our problem and implement it, right? So we will build up an intuition using two data structures, one to store the numbers and another to store the strings, correct? Then we moved ahead. Then we understood why we are using stack and how it is a problem of stack, right? So I hope you understood this intuition build up. The question is very easy and very straightforward. So I hope you understood it. Now let's go to the next slide. Now, since we got the intuition of the problem, let's look into the approach, how we're going to solve it. So we initialize the tools for building the final string, fine. We start by setting up three important variables, num stack, string stack, current number, and current string to store how many times we need to repeat pattern, and string stack to remember the strings we build so far, and the current number we are reading and the current string we're building. Now keep in mind, in Python, there is no stack or no inbuilt stack is present. So we use array or list to implement stack, correct? Keep that in mind. And we use the concept of stack. Now, what is the concept of stack? LIFO. Fine. What does LIFO stands for? Last in, first out. Okay. Basically, the value which comes or entered lastly, or the most recent value which got entered, will be popped out first. Fine. It's basically putting something in a rack, and the topmost value is always taken first. Fine. So how these tools will help us to build up help us to build a decoded string from inside out, especially when we have nested brackets like this. Correct. Now after that, what we do? We traverse the encoded string character by character, loop through the each character in the string. We have to loop through the each character in string, of course, and each step we decide what kind of character it is, whether it is a digit, whether it is an opening or closing bracket, or it is a character or a string. Fine, and take the action accordingly. Okay. This is the build-up of our approach. Now let's move to the next steps. Handling numbers and build the multiplier. Now this is seems a bit complex thing, but it is not. Like if you see a digit like 3, it might not be a part of a multi-digit number like 12. What I'm trying to say here is if it is a 3, you could directly take it, convert it to a number, and then you can just go ahead. But if it is 31 and it is a string, right? So you have to make this a complete 31 as a number, right? So what you do, you multiply the current number by 10 and add the new digit. So what you do, you do the current number 3. The current number right now is 0. You multiply it by 10, add the 3. So when you do this, we convert 3 into integer, and 0 into 10 becomes 0, correct? Plus 3 gives me 3. Then again you go, then you get 1. You have 3 as current multiplied by 10 plus converting string 1 into an integer. You get 30 plus 1, then it's 31, right? This is what we are doing here. Why? To support multi-digit number, as I already said. If it is 12, if it is 31, if it is 431, whatever, whatsoever. The range is from 1 to 300 as said in our constraints. Got it? Now step 4. The start of a new encoded block. This is an interesting part. Let me clear this. Now we have the data structures to store the values and the strings. We have the numbers, check for the values, how many times you have to repeat it. Okay. Now comes the real task, encoded block. Now, whenever we hit an opening bracket, it means we are about to start or building a new pattern, correct? Now, before doing that, we push the current number. Now, before every opening bracket, there would be a number which is basically k, correct? So we push it into the stack because we will be needing it later, right? And we push the string to the string stack. So till now, whatever string which we have created, we push it into the stack. We don't directly push the bracket in our approach. We just directly push the string. Okay. Now, when we reset our current num and the current string for the new block. Okay. So you got this pattern. Supposed you have this, right? You will push this into the number stack. Then you will find that, okay, we have the opening bracket. Then you take this complete string, okay, and you push it into the stack. Correct? This is the thing you do. Point number 2.2. Then you make these variables in which you have stored this value and this string empty. Why? Because this is one thing, right? Again, you got a number, again, you got an opening bracket. You need a refresh start or a restart, reset kind of a stuff, right? That's why we reset everything. Okay. This is the code it would look like. We will append the current number to it. We'll append the current string to the string stack. We clear them out, cleared out the variables. Why we do it? Again, we're entering a new nested layer of the substring or the string. Just like in math, when you hit an opening bracket, you remember that what came before it, right? And deal with the inside first. So we have to remember what came before and what is coming right now. So that's why we put it in the stack and refresh the current variables. Now, after the step 5, we got the closing bracket, right? So when we see a closing bracket, it finishes the current mini pattern. Since we resolved a few of these things, right? Let's take something like it is resolved, right? So it becomes 2 a, and we got this closing bracket, right? So what we do? We pop from the stacks. So whatever we have saved in the stack till now, for example, we had 2, then 3, right? In one of the stacks, and in another of the stack we had a, then we had C, right? What we do? We pop this, we pop the C, right? We pop the 3, right? What we do? We multiply this character with this, okay? Current string multiplied by num. So C is not stored in the stack basically, or you could say it is present in our current string. Current string has C. So we multiply it 3 times, you get triple C. And in previous tree, we pop this, right? We have A. Now you have been confused. Now what's happening here? Let me explain it again. Previous string means the string which is present in our stack. Fine. It is a string. Previous nums means we had few numbers here, 3, 2, 4, whatever, right? Whatever number is there. So nums takes this number. Previous string takes. Suppose in the stack you had values, right? A, B, C. This is the string you had, right? You pop this. You keep it here. Now current string has the current string in the value, right? In a string, you had CC, you encountered CC while traversing you know, the string. So you have this, right? CC here. Now you will take this CC, multiply it 4 times. You get CC, C, 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 C. Okay, this is you got the mini expression. Now you will add this expression to the previous string, which is ABC. So our string becomes ABC and plus C, 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 C. Okay, you get this, then you store it back into the stack. Correct? Also, this is the thing which you are doing in step 5. We are doing this because when you solve an expression, you have to add it with the previous string because it's like this. You solve this, right? Now A is there, so this complete solvable string will be together. Okay, I hope you understood this part. Now we build a current string. Now here, if you could see, till the time we are not getting the closing bracket, we keep on adding into the current string, right? Like A, B, C, D, keep on adding it into the current string variable, right? Okay. Now at the end, we return the current string only because at the end, the current string will consist of the complete and decoded string. Now, how stack is helping us in this case, right? We are using a LIFO structure which matches the nested bracket processing. When we hit a closing bracket, we need the most recent number and string, right? So stack gives us that instantly. If you observe, we are just copying the correct character or the topmost character from the stack and the number also. So this is the concept of LIFO in stack. Then easy context switching. We basically, before entering a new expression, we save the current string and number using stack. So we return it to it after the finishing the nested path. So handles multiple level of nesting. As I explained, if there are multiple level of nesting, this also helps in storing into the stack so that we could manage it more efficiently without any confusion. Now building final string in one pass. This is the most easiest way because if we haven't used tag, the times that time complexity would have been n square or much more than that since we had been iterating multiple times the same thing, correct? Okay, now let's move to the next slide. The code is the exact copy of the approach discussed. Okay, now we have the num stack and the string stack. This is the stack for the numbers and the string. And this is the current number and this is the current string storing variables, fine? This stores the length of the string, given string. Okay, this is the complete range for loop. If it is a digit, we're checking, we do this multiplication to store it in our current num. If it is an opening bracket, we do this function. We just put the current num into the number stack, then current string into the string stack, then you make that empty. If it is in closing bracket, we take the latest number from the stack, number stack, we pop it, we throw it out. Fine. We take the previous from the stack and previous value string from the stack, and since we are recording the current string here, we take this, I explained this calculation previously, and at the end we return the string. Now the time complexity comes out to be O of n. Because this is only one pass solution, we are just iterating one time and it is of length O of n. Correct? Space complexity is O of n since we are using two stacks, which basically counts to be O of n plus O of n. Not exactly O of n, it's nearly n. It is also nearly n, but if we add it, it's O of n completely. So that is the thing. So I hope you understood this code explanation. It's pretty simple and straightforward. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of this example. Before that, let's store some declare some variables so that it helps us in our solving the problem. Num as that is the num stack. Then num, sorry, not num. That will be strs as the empty stack. Then current as current string. Then current num. Let it be these two variables. Let it be previous previous of as previous string. Okay. And also we will store one formula here. During the loop, if you remember, current string was equals to previous s plus current s multiplied by current or the num which we popped, or we could write it as num s minus 1 topmost value. Fine. We could just save it here. Great. So let's start writing. We are in 2, right? So 2 means it's a num. So we convert it into a value, integer value, and we store it in the current num. Then we move ahead. We get an opening bracket. As soon as we got the opening bracket, what we were doing? We were appending this current num to the num stack and the current string into the string stack and resetting the value. Since string stack is empty, it won't be doing anything special there. So we will move ahead. Okay. Then we had A. So we stored A in the current string. If you remember, at the else case, we had current s of I, right? Great. A. Then we got B. Then we got C. Then we got the closing bracket here. As soon as we got the closing bracket, what we were doing, we were taking out the previous s. Previous s is basically string of s minus 1, topmost value from the string stack. So it is empty right now. Plus current is what? Current is ABC, correct? And it is 2. So it will get multiplied by 2. And nums of s basically means nums of stack topmost value. So we get ABC 2 times. So since you got ABC 2 times, it gets saved in the current string only. Then we move ahead, and we also we remove this number of this value from here. We moved ahead. We got 3. So again we got 3. So we will store it in current num. Again, we got a starting bracket. As soon as we got the starting bracket, what we do, we put this current num3 here. Okay, this string, current string in our string stack now. Now we have the current string has some value right now, and we reset these values. Now we moved ahead. We got C. We got C. Then we got D. Correct. Then we got the closing bracket here. As soon as we got this closing bracket here, what we were doing, we come and we take out, we make a complete, we solve the equation basically, right? So here what we did, to the previous string is basically string or string stack topmost value, which is ABC, ABC in this case. So ABC, ABC plus current string is CD and multiplied by num stack topmost value, which is 3. So it results in ABC, ABC, CD, CD, CD. Okay, and it gets stored in our current string. Write it here. ABC, 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 CD, CD. Okay, and CD one more time because 3 ABC, CD, CD, CD. Okay, fine. So this is the thing. Then we got after that we iterate, we got E. E gets attached here. F F gets attached here, and iteration is complete. So at the end we return the current string itself, and you could see we have ABC, 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 ABC. Have written mistakenly 3 times ABC here. You could see ABC, ABC, then CD, CD. Clear this up. Now you could see I have 2 times ABC, then CD is 3 times, okay, and EF 1 time, okay. So we got the current output or the correct output, we would say. So if you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition again, the approach and the code, and also the stack concept. And after that, do a dry run by yourself on 2 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. And I understand the problem was overwhelming, and the explanation was also overwhelming, and a bit of confusion here. But the concept is pretty straightforward and clear. So now let's move to the next slide. Now, since you're familiar with the problem and solution, let's move to the lead code and code the solution. We will create a number stack here first. Okay, we will create a string stack. Then we'll create current as to store the current string. Then we'll current and to store the current number to be 0. Then n equals to length of the s. Then for in range of n, go, and if s of I is digit in current num, we would be having current num. We will do the calculation into 10 plus integer of s of I. Correct? Else, if it is not a number, and else if it is an opening bracket s of I, if it is an opening bracket, the num stack, we will append the current number, and in string stack, we will append the current s, correct, or the current string, and we will reset the current string to an empty string, and current num to 0 again. Fine. Again, else if s of I is an closing bracket. Now what we will do? So we will pop out the topmost value from the num stack, num stack dot pop. Okay, and we will have the previous string here, which will carry the previous string, or we could say str stack dot pop. We get the previous string stored in the stack, or the topmost string in the stack, then current string will get updated with previous s plus current s multiplied by nums. Okay. Else case, until unless we don't get any other stuff like that, we keep on adding the string here. And at the end, we return the current s. Now let's submit the solution. Okay, now let's finally submit the complete solution. So we can see that our solution got accepted here. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.